If I was going to give a bio sketch of what's happened in software engineering, it's really, over the last 60 years, it's a migration from plan and document towards Agile. And that doesn't mean that Agile has completely displaced plan and document, but we've seen a lot more scenarios where a way of doing things differently from what was originally conceived as software engineering has turned out to make some sense. And to illustrate this, let's talk about software's greatest hits. We've got, let's see if this is a little kinder to me now. If I actually, yay, the right thing.
Aircraft manufacturers have tried to fix that problem by designing the pilot out of the cockpit. This is the first fully automated plane, flown by a computer.
That's Forrest, by the way.
Oh no.
Okay, so in case you don't speak French, oh la la is French for osh. Hold on, let's, there's more.
Décollage.
Décollage means takeoff. Okay. Okay, so I'm sure somebody there also said ooh la la, and we just didn't hear it. Those were both software bugs. The hardware was working as designed, but something in the integration of different software subsystems wasn't thoroughly enough tested. And if you'd like to read about a lot more software bugs just like that, I encourage you to follow this link. And the slides are up right after lecture. But history's worst software bugs. This is like 2 out of a collection of 20. So why does this happen? Why is it that, when they build buildings, the buildings don't just arbitrarily fall down? When they build bridges, the bridges don't just arbitrarily collapse. So why can't we build software the same way that we build things like infrastructure? Now, leaving aside the fact that in real life, 90% of infrastructure projects actually are late or over budget. The light rail they're trying to build out to the ballpark, in case you don't believe me. But at any rate, they don't fail so spectacularly for the most part. And what are we doing wrong in software in some sense that we can't do that? So the original idea was, let's do software projects the same way we do infrastructure projects. And a family of approaches that we're loosely going to call plan and document, which is essentially you do a lot of planning up front, and you only go from the planning stages to the building stages when everybody is in agreement on what the next step is supposed to be. So there's a project manager who makes a plan. You have very detailed design documents. You know where you're supposed to be at any given point in time, so you can have a way of measuring your progress. And if any changes happen, those changes have to be retroactively reflected all the way back to the design docs or whatever. You've probably heard of this. It's called the waterfall lifecycle or the waterfall development model. And basically, the software project, like a real project, goes through 5 phases. In the first, you figure out what it is you are supposed to build. What functions does it need to perform and under what circumstances? What is the architectural design? In other words, what is the collection of large subsystems that are going to be put together to make this piece of software work? Once you've decided that, you can actually get on with the task of creating it, writing the actual code for the subsystems, linking the subsystems together. Somebody's got to figure out that you actually, wow, that was interesting. That's fun. There's supposed to be a thing there that says verification, that it doesn't have bugs. I like that, don't you? Verification, or what some might call testing after the fact. You built it, but did you build it right? Does it actually function the way that you thought it would? And finally, you put the thing into operations, and you do whatever is required to maintain it. Each phase has to be complete before you start the next one, because the philosophy is the earlier you find a mistake, whether it's in your documentation and your design requirements, the cheaper it is to fix. Right? It's easier to add an inch to the car before it comes off the assembly line. It's easier to make a critical change to the software before all of the tests and code have been written and deployed. That was the idea. So, is that a successful model for software development? You might think this is the place where I'm like hating on the waterfall model, but no. In fact, another article that I encourage you to read called They Write the Right Stuff describes how the team that, until the space shuttle was retired a few years ago, the team in charge of the space shuttle software, which is immensely complicated. The space shuttle basically flies on autopilot the whole time. So the software system is a bear, and yet, in a 420,000 line of code base, each of the last 3 versions has had 1 or 0 bugs. That's amazing. right? Commercial software of that size would have hundreds of bugs if you're just looking at the statistics. It's a team of about 260 developers. It's one of only 4 software shops in the entire world that has earned the most mature, most sophisticated, highest maturity rating from the Software Engineering Institute. Maturity is a way of measuring the extent to which your organization can measure and feed the results of its process back to improve the process. So can you predict how many bugs you're going to have? And how good are you at doing that? How good are you at predicting when you've done enough testing that the next bug will take many years to find? And they did this by rigorously adhering to that model. There's an anecdote about how at one point they had to change about 6,000 lines of code, which is less than 2% of the code base, to add support for GPS satellite navigation. And that turned into 2,500 pages of documentation that could be written before anybody could change or write a new line of code. So this is taking the waterfall process to an extreme. The problem is it wasn't as successful an approach for software development for other kinds of software. In particular, what is a property of things like space shuttle software that might not apply to, I don't know, a new ride-sharing app, financial reporting for a startup, things like that? What are properties of the kind of software like the space shuttle team that might actually think this is a good way to do it? It can be permanent, and it's or at least very, very rarely updated, right? So if the thing that you're writing is like, and it's like a bridge, right? When you build a bridge, you don't finish building it and then say, you know, we really should have had 3 lanes in that direction. Can you modify it to add a lane? Although they did that to the San Mateo Bridge a few years ago. And by the way, it costs more to add a lane to the San Mateo Bridge than it costs to build the entire bridge in the first place in adjusted dollars. So yeah, if you're not going to change it very frequently, then having a very rigid specification and a very heavyweight process anytime a change has to be made makes some sense. It allows you to do a much more thorough job of checking, did the specification really cover all the circumstances? Does the implementation really do what the specification says? But if you're building something that may evolve, and this is something you should get used to hearing from your soon-to-be customers in this class, it's just what we asked for, but not what we want. The user and you will come to an agreement on what you're building, and once the user tries it out, they'll say, that's exactly what we asked for, but now that we actually try it out, it'd be better if you had done it this way. Could you just change it and do it that way? And this is the fundamental insight of Agile, in my opinion. The strength of software is that you could say yes. You can change software. It's not like changing a bridge. However, the waterfall process is not one that is really good about gracefully handling change, as we've seen. So that's one of the characteristics that, if you're building something that's customer-facing, and your customers might want changes sort of on an ongoing basis, you need a process that does a better job of handling that. So what happens if you don't do that? Again, another great article, the Software Wall of Shame, looking at a collection, 3 different big surveys of big software projects, looking at projects that were later over budget, so over 50% in the first study, and 20% in another study. Projects that were on time and on budget, only 16% in the main study. And projects that were never even finished. They went so off into the weeds that they were just abandoned, and all the money sunk into them until that point just had to be left on the table. And by the way, when I say on time or over time or over budget, it was about a factor of 3 on both of those things. So not a great track record when you try to take the kind of project where customers might change their minds, but you try to apply a development methodology that is a poor fit for that. So what could you do instead? Well, one thing you could do is, and Fred Brooks is given credit for this quote, throw it away. You build one whole system according to that methodology. With the benefit of 20/20 hindsight, you know what you should have built, so now you build it again. Not a super economical way to do things, but it was kind of an early lesson in software engineering of like, yeah, you might think you can specify the whole thing, but if you're, in some sense, coding to a moving target, you're going to have to do something to reconcile that reality with it's not part of your plan. So, yeah, after you build the first one, you know what you should have done, but is the best thing to do really to just discard the effort and start all over again from brand new code? I mean, can't we do better than that? So an improvement on the waterfall was, okay, well, let's try this instead. If you think of time as going sort of clockwise around the spiral, early on in the process, we'll build a prototype. And the prototype will only implement a subset of what the product is supposed to do, but it gives the customer a chance to get some feedback that might influence building the next prototype, and the next one, and the next one, and eventually you've thrown some prototypes away, but a prototype is a lot less work than the full system. So you learn a little from each one you throw away. You eventually get to the actual system you wanted to build. Certainly an improvement, because each time you're getting a new prototype, it's based on feedback about what you could have done better in the previous one. But those prototypes may still be pretty far apart in time. What you're really doing is mini waterfalls, each of which ends in a prototype that lets you learn something from having tried to build it. There's a variant of this called the rational unified process, where you're building prototypes, but you can sort of overlap the production of one prototype with the beginning of the design phase for the next one. But still, you're talking about doing things that are far apart in time. And one way to think about the motivation for things like Agile is, if I build a prototype now, and I'm going to wait X number of months for the customer to be able to give me feedback on that prototype, that amount of work in between is the risk I'm taking, assuming that I'm going to do the right thing. So the longer I go without feedback or without learning from what I've built, the more I increase the risk that the thing I'm building will not make sense, that I will have had to waste some effort.